makes exercise 11.05 on integration, A-level pure maths, year 2. We've got 3 questions. Question 1. A. Find the integral of 6 sec squared x minus 4 tan squared x with respect to x between the limits 0 to pi over 4. B. Given that the integration of 2e to the power x over e to the power x plus 1 with respect to x between the limits of ln 2 to ln a is equal to ln 4, where a is bigger than 0, find the value of a. So for a, I'm going to use trig identities to simplify this. And the trig identity I'm going to use is 1 plus tan squared x is equal to sec squared x. If I rearrange this to make tan squared x the subject, I'm going to get tan squared x is equal to sec squared x minus 1. So I'm going to use this identity to simplify this first before proceeding to integrate. So for the simplification, I have 6 sec squared x minus 4 tan squared x will become 6 sec squared x minus 4 brackets sec squared x minus 1. So I'm now going to expand this to get the following. 6 sec squared x minus 4 sec squared x plus 4. These two terms are like terms, so we can simplify further to get 2 sec squared x plus 4. So now that this expression has been simplified to this, I can proceed to do the integration as follows. The integral of 6 sec squared x minus 4 tan squared x dx between the limits of 0 and pi over 4 will be equals to the integral of 2 sec squared x plus 4 with respect to x between 0 and pi on 4. I can now proceed to integrate and know that the integration for sec squared x is tan x, so I have 2 tan x between 0 and pi over 4 plus, if I integrate 4, I get 4x also between the limits of 0 and pi over 4. If I do my substitution for this term, I have 2 brackets tan pi over 4 minus tan 0 plus 4 times pi on 4 minus 0. So we have 2 brackets, tan pi over 4 is 1, and tan 0 is 0, plus this will cancel out, and I'll be left with pi minus 0. So simplifying that, we're going to get 2 plus pi, and we can also write it as pi plus 2. And that is the answer required for 1a. So for b, I have 2 e to the power x over e to the power x plus 1. Integration of that with respect to x. If I let u equals to e to the power x plus 1, that is the denominator, then du will be equals to e to the power x dx. So the whole of this integration can be written in terms of u as follows. The integral of 2 e to the power x over e to the power x plus 1 dx will be equal to 2 integral of 1 over u du. Because this 2 is here and the e to the power x dx is replaced with du, because we said du is equal to e to the power x dx. And obviously the e to the power x plus 1 is replaced with u, as we said here. But now this can easily be integrated as follows. This will be equal to 2 ln u. So the whole integration with the limits can now be written as follows. So the integral of 2 e to the power x over e to the power x plus 1 dx between the limits of ln 2 and ln a will be equal to 2 ln e to the power x plus 1, which is the u over here, between the limits of ln 2 and ln a. But we know that this expression, as stated in the question, is equal to ln 4. So it follows that we can equate this to ln 4. So if we do that, we're going to get 2 ln e to the power x plus 1 between the limits of ln 2 and ln a is equal to ln 4. So I'm now going to do my substitution to find the value of a. So if I do the substitution, I'm going to get 2 ln e to the power ln a plus 1 minus ln e to the power ln 2 plus 1, and that will be equals to ln 4. We can now simplify to get 2 ln a plus 1, because e to the power ln a is equals to a. And so that's why this becomes a here, and we have our 1 over there. So we continue with this, and we get minus ln. And the same way, this will become 2 plus 1. That will be equal to ln 4. So if I can simplify this further by saying 2 ln a plus 1 minus ln 3 equals to ln 4. I can now use the laws of logs to rewrite this as follows. 2 ln a plus 1 all over 3 is equals to ln 4. Using the laws of logs again, I can say ln a plus 1 all of that over 3 squared is equals to ln 4. So because we have ln a plus 1 over 3 all squared equals to ln 4, we can say that a plus 1 over 3 all squared is equals to 4. So we have a plus 1 squared over 9 is equals to 4, which means a plus 1 squared is equal to 36. So a plus 1 is equal to plus or minus square root of 36, which means a plus 1 is equals to plus or minus 6. So we can now have two values. One will be a is equal to 6 minus 1, which is equals to 5. And the other value will be a is equal to minus 6 minus 1, which will be minus 7. But we are told that the value of a is greater than 0, and so the valid answer for this is a is equals to 5. And that's the answer required. Question 2. A. Find the integral of cos to the power 5 of x dx. B. Given that k is a positive integer, show that the integral of 4 over 5x plus k between the limits of 3k to 4k is independent of k. So for A, we have integral of cos to the power 5 of x dx. So I can rewrite it as integral of cos x to the power 4 times cos x dx. Now we know this from year 1 maths that sin squared x plus cos squared x is equal to 1. It means that cos squared x is equal to 1 minus sin squared x. So I'm going to substitute 1 minus sin squared x in here. And if I do that, I'm going to get equal to the integral of 1 minus sin squared x, all that squared, because this is raised to the power 4, times cos x dx. And if I expand, I will get integral of 1 minus 2 sin squared x plus sin x to the power 4, all of that times cos x dx. So now to let u equals to sin x, which means du is equals to cos x dx. So now I can rewrite the whole integral as follows. The integral of cos x to the power 5 dx is equal to integral of 1 minus 2u squared plus u to the power 4 du, because the cos x dx is replaced by du, as we've seen here, because du equals to cos x dx. And this is 1 over here, 2u squared, and u to the power 4. I can integrate this easily as follows. U minus 2 over 3 u cubed plus 1 over 5 u to the power 5 plus my integration constant. So now the final answer can be written as sin x minus 2 over 3 sin cube x plus 1 over 5 sin the power 5 of x plus the integration constant. And this is the final answer required. For B, I've got integral of 4 over 5x plus k between the limits of 3k and 4k with respect to x. So let u equals to 5x plus k, and therefore du will be equals to 5 dx. I want dx, so I'm going to say 1/5 of du equals to dx. That means I can replace dx with 1/5 du. So the whole integration, which is 4 over 5x plus k with respect to x, from 3k to 4k can be written as integral of the 4, which is here, over u, because I'm replacing this with u, so I get u here, times the dx, which can now be written as 1/5 du. But we need to put different limits here, so let's go and get those limits. So we can make a small table like this. Our values for x will be here, and that for u will be there. So when you have 3k, I put 3k here, I'll get 3 times 5, I'll get 15k plus k, that will be 16. So when x is 3k, u will be 16k. In the same way, when 3 is 4k, I get 21k. So we've got new limits, and we can put them in here. So I have 16k here, and 21k over there. I can write this again as follows. Integral of 4/5, 1 over u du, which should be equal to 4/5 ln u. But we have to put our limits in. 16k, 21k here, and then 16k here, 21k over there. We can now evaluate. So that will be equals to 4/5 ln 21k minus ln 16k. This can be written as 4/5 ln 21k over 16k. And that can be reduced to 4/5 ln brackets 21 over 16. And as you can see, the final answer does not involve k, and so that it's independent of k. So this is the final answer for question 2b. Question 3. Using the substitution u is equal to cosec x or otherwise, find the exact value of the integral of cot cube x dx between the limits of pi over 4 and pi over 2. So I'll begin by rewriting the integral in a different form as follows. Integral of cot cube x dx is equal to integral of cot squared x times cot x dx. Then I'm going to use trig identities to replace cot squared x. And the trig identity I'm going to use is 1 plus cot squared x is equals to cosec squared x. If I make cot squared x the subject, I will have cot squared x is equal to cosec squared x minus 1. So in that case, I can replace cot squared x with cosec squared x minus 1. And so this will be equal to integral of cosec squared x minus 1 times cot x dx. I'm now going to expand this to get the following. The integral of cot cube x dx is equal to integral of cosec squared x cot x minus cot x dx. Then I'm going to separate this into two parts as follows. Integral of cot cube x dx is equal to integral of cosec squared x cot x dx minus the integral of cot x dx. Then I can put my limits in as follows. So we have pi over 4 here and pi over 2 here. So pi over 4, pi over 2, pi over 4, pi over 2. So now that we have two parts on the right-hand side, we can integrate them separately. We can deal with cot x dx first. Now, the integration of cot x dx is ln sine x. But how do you get that? So, integral of cot x dx can be written as integral of cos x over sine x dx. Then let v equals to sine x. In that case, dv will be equals to cos x dx. So now, the integral of cot x dx becomes the integral of 1 over v dv. Because cos x dx can be replaced by dv, and obviously sin x will be replaced by v. Now, 1 over v dv can be integrated easily to get ln v. So, cot x dx becomes ln v. And since v is equal to sin x, we end up with ln sin x. And so now we can replace this integration with ln sin x, and we'll do that later. So for now, we turn our attention to this term here. So for this term, let u equals to cosec x as given in the question. In that case, du will be equals to minus cosec x cot x dx, which implies that minus du is equals to cosec x cot x dx. So the integration of this term can now be written as integral of cosec squared x cot x dx can be written as integral of cosec x times cosec x times cot x dx. Now we can see from here that this part here is the same as minus du. And since we said u is equal to cosec x, which is this, we can reduce all that and write it in terms of u as follows. So that will be equal to minus the integral of u du. And we can integrate that easily to get minus half u squared. I can now do my integration of cot cube x dx between the given limits as follows. Integral of cot cube x dx between the limits of pi over 4 and pi over 2 will be equal to the integration of cot squared x cot x dx we got to be minus half u squared, where u is cosec x. And so that becomes minus half cosec squared x minus, and the integration of cot x dx will got to be ln sine x. So let's put that one in, ln sine x, and then we can put our limits in. That will be pi on 4 and pi on 2. But cosec x is the same as 1 over sine x. So I can write the whole of this equation here using sine as follows. The integral of cot cube x dx between pi on 4 and pi on 2 will be equal to minus 1 over 2 sine squared x minus ln sine x between the limits of pi on 4 and pi on 2. Now it's time for us to do our substitution to evaluate the integral. And we're going to do that step by step, putting in first pi over 2 and then pi on 4. So let's get the values when x is pi over 2. So when x is equal to pi on 2, then I'll have sine pi on 2, which is 1, and 1 squared is 1. So I'll have minus 1 over 2 sine squared pi on 2, and that will be equal to minus 1 over 2 times 1, and that will be equal to minus a half. And then this second term here will be ln sine pi on 2, and that is ln 1, and ln 1 is equal to 0. So that is for the upper limit. For this limit here, pi over 4, when x is equal to pi on 4, sine pi on 4 is root 2 on 2, and square that, you're going to get a half. So for this term here, I'll have minus 1 over 2 sine squared pi on 4, and that will be equals to minus 1 over 2 times a half, and that equals to minus 1. Similarly, when x is pi on 4, this term here will become ln sine pi on 4, and that will be equals to ln root 2 on 2, because sine pi on 4 is root 2 on 2. We can now do our substitution appropriately, and this is what I'm going to get. When x is pi over 2 in this term, I'm going to get minus a half, and when x is pi over 2 in this term, I'm going to get 0 minus. Then I put both pi over 4 here and there, and I'm going to get minus 1 and minus ln root 2 over 2 respectively. So now I'm going to simplify that, and I'm going to get minus a half plus 1 plus ln root 2 on 2. Minus half plus 1 is a half, so I get a half plus ln root 2 on 2. I can rewrite this one, and I'm going to get half plus ln 2 on 4, all of that raised to the power half. I can use the loss of logs here, and I'm going to get half plus half ln 1 over 2. Because 2 over 4 is 1 over 2. I'm going to factorize the half out, and I'm going to get 1 here plus ln half over here. If I simplify further, I'm going to get half brackets 1 plus. And using the laws of logs for this one, I'm going to get ln 1 minus ln 2. But ln 1 is 0, so I get half 1 minus ln 2. And this is the exact value of the integration required. And this brings us to the end of this session on mixed exercise 11.05